Bismillahirrahmanirrahim. Assalamu alaikum students. In this video we will solve some parts from the question number 7 and few parts from question number 8. In question number 7, universal set is given whose members are 1, 2, 3, 4, 5, 6 and 7, and set A is given whose members are 1, 2, 5, 7, and set B is given to us whose members are 1, 3, 6 and 7. Let me discuss the first part of question number 7, that is they ask to find A complement, and we know that A complement equals to universal set minus A. So the first set is universal set whose members are 1, 2, 3, 4, 5, 6 and 7. Then put the sign of minus and then set A whose members are 1, 2, 5, 7. Now A complement is a set of those members of universal set which are not present in A. Clear? 1 is present in A, so it will be subtracted from universal set. We will not write 1 in this set. 2 is present in A, so we will skip 2 also. 3 is not a member of set A, so we will write 3 in the resultant set. 4 is not a member of set A, so we will write 4 here. Similarly, 5 is the member of A, so we will not write 5 in the resultant set. 6 is not the member of set A, so we will write 6 here. 7 is the member of set A, so we will not write 7. So this is the set of A complement, whose members are those members of universal set which are not present in A. Simply you can say we will subtract these members from universal set. Okay, let me consider part 3. In part 3 we have within a bracket we have A intersection B, and then we have whole complement, means A intersection B whole complement. Within a bracket we have A intersection B, so first of all we need to find A intersection B. First we write the set A whose members are 1, 2, 5 and 7. Then we put the sign of intersection, then set B whose members are 1, 3, 6, 7. Now intersection means a set of common elements of these two sets. Now which elements are common to A and B? A is common because it is present in both sets, so first of all we will write 1. 2 is not common, 5 is not common, 7 is common to A and B because 7 is the member of A and B, so it is common to A and B, so we will write 7 here. So A intersection B will be equals to a set containing 1 and 7. Once we get this set, what we will do? We will take the complement of this set. Now for complement we have a formula. U minus, U mean universal set. Universal set minus the set of A intersection B. A intersection B. Now universal set is a set whose members are 1, 2, 3, 4, 5, 6 and 7. And A intersection B is a set whose members are 1, 7. Now A intersection B whole complement is a set of those members of universal set which are not present in this A intersection B. So we will write 2 because 2 is not present here. Then we will write 3. Then we will write 4, 5 and 6. 7 is present, so we will not write 7 here. Simply we can say we will subtract 1 7 from the universal, and we will write the remaining members of universal set. Now consider part 5. In part 5 we have A complement union B complement. Now this time we need A complement and B complement first, because the set A and B are given, but A complement and B complement are not given to us. So first we need to find A complement, which is equals to universal minus A. Universal set is a set whose members are 1, 2, 3, 4, 5, 6 and 7. And A is a set whose members are 1, 2, 5, 7. So when we subtract these members from universal, what we will get? We will get 3, 4 and 6 only. Means the set of those members of universal set which are not present in A. Okay, now we need to find B complement, and B complement equals to universal set minus B. Universal set is a set of 1, 2, 3, 4, 5, 6 and 7, and B is a set whose members are 1, 3, 6 and 7. When we subtract the members of B from universal, what we will get? 2, 3 will be subtracted, we will get 4, then 5. 6 and 7 are present in B, so we will skip them. So B complement is a set of 2, 4 and 5. Okay, now we got the set of A complement and B complement. The next step is to take the union of these two sets. A complement union B complement. Now A complement is a set whose members are 3, 4, 6. 3, 4, 6. Then we will put the sign of union, and then B complement is a set whose members are 2, 4, 5. 2, 4, 5. Now union means that we will write the members of A and B in a single set. Means union of A complement and B complement is a set of those members which are from A complement or from B complement or from both A and B complement. Clear? A complement and B complement. So we will write 2, we will write 3, we will write 4, we will write 5 and we will write 6. So this is the union of A complement and B complement. Clear? Okay, now question number 8. In question number 8, universal set is given whose members are 1, 2, 3, 4, 5, and set A is given whose members are 1, 3, set B is given whose members are 2, 4, and set C is given whose member is 5 only. In first part they asked A union B union C. Okay, now there is no bracket. Clear? So what we will do, we can write it as set A whose members are 1, 3, then we will put the sign of union, then we will write set B whose members are 2, 4, then we have set C whose member is 5 only. Okay, now we can take the union of all the three sets in a single step. And union means that we will consider the members of all the three sets. Clear? So the union of all three sets will be equals to 1, 2, 3, 4 and 5. So this is a union set for all the three sets A, B and C. If you want to show this by a Venn diagram, we know that Venn diagram is a pictorial representation of sets. For universal set we use rectangle. Yeah. So this rectangle shows the universal set. And all these three sets are the subsets of universal set. So we will show them within rectangle. And the subsets are represented by circles. And all these subsets are disjoint sets because they have no common member. So all the circles are disjoint circles. Clear? The first one is A, whose members are 1, 3. The second one is set B, whose members are 2 and 4. And the third one is set C, whose member is 5. Clear? Now the union of these three sets equals to the universal set. Clear? And we represent the union by shaded portion. So we will shade all the whole rectangle because their union equals to universal sets. Clear? And this diagram now shows A union B union C. Okay, let me discuss another part. Okay, let me discuss part 3. In part 3 we have bracket A intersection B union C. Now this time bracket is involved. So first we will simplify the bracket. Okay, now within a bracket we have set A whose members are 1, 3, then intersection, sign of intersection, then set B whose members are 2, 4, then bracket close, then sign of union, and then set C whose member is 5 only. So first of all we will simplify the bracket. Within a bracket we have intersection of A and B. Intersection means set of common elements of A and B. But A and B are disjoint sets. They do not have any common member. So their intersection set will be empty. Clear? Then we have union sign and then set C whose member is 5. When we take the union of empty set with set containing 5, what we will get? We will get this set as a resultant set. Is it clear? Because there is no member in empty set which will be added to this one. So we will simply get this set as a union set of these two. Now what we will do, if we want to represent them by Venn diagram, we can split it into two steps. The first diagram can be shown The first diagram is for the bracket. Clear? What we have in a bracket, we have A intersection B. So A is a set whose members are 1 and 3, and B is a set whose members are 2 and 4, and this whole rectangle representing universal set whose members are 1, 2, 3, 4 and 5. Now A intersection B is a set which is equals to an empty set, means there is the resultant set is empty, so no part will be shaded. Clear? This simple, the rectangle and this circle shows A intersection B. Clear? Because we have an empty set, we do not have any common member between A and B, so that's why we will not shade any part of the rectangle. Okay, now the second part is the union of bracket with C set. Now if we draw a rectangle for them, what we will do, we will draw a rectangle for universal set. Now the resultant set of, within a bracket we have A intersection B, and that is an empty set. A intersection B. Finally we take the union of A intersection B and set C. So this is an empty set which shows A intersection B. So A intersection B will be an empty circle, and then we will show set C whose member is 5. Clear? And the whole universal set have 5 members. So 1, 2, 3, 4 are out of these two circles. Now the resultant of these two sets equals to 5. So we will shade only set C, because set C representing only 5. So this is the final diagram for intersection B union C. Okay students, I hope you got the idea of Venn diagram and how to simplify the brackets. Now let me discuss part C of question number 8. In part 8, the given sets are universal set whose members are 1, 2, 3, 4 and 5. A is a set whose members are 1, 3. B is a set whose members are 2, 4. And C is a set whose member is 5 only. Now in part C they asked to prove De Morgan's laws. Now we have two parts of De Morgan's laws. A complement union B complement equals to A intersection B whole complement. This is the first law, and the second De Morgan's law is A complement intersection B complement equals to A union B whole complement. So I will prove one of them for you, and you will try the second one by yourself. Clear? Okay, I will prove part law 1 for you. That is A complement union B complement equals to bracket A intersection B whole complement. Okay, now in this identity, those values which are at the left hand side of sign of equality, this is called left hand side. So first of all we will consider left hand side, whose value is A complement union B complement. Now we need to find the value of A complement and B complement first. So we know that A complement equals to universal set minus A, and universal set is a set whose members are 1, 2, 3, 4 and 5, and then we have set A whose members are 1, 3 only. Okay, now we know that A complement is a set of those members of universal set which are not present in A. So we will subtract 1, 3 from universal set and we will write 2, 4 and 5. This is A complement. Then we need B complement. And we know that B complement equals to universal set minus B. Universal set is a set whose members are 1, 2, 3, 4 and 5. And then we have set B whose members are 2, 4 only. Okay, now B complement is a set of those members of universal set which are not present in B. So we will subtract 2, 4 from here. We will get 1, 3 and 5. Now we have A complement and B complement. So finally we will take the union of these two sets. A complement union B complement. A complement is a set whose members are 2, 4, 5. Then put the sign of union. And B complement is a set whose members are 1, 3, 5. Now union means that we combine the members of both the sets in a single set. So we have 1, 2, 3, 4 and 5. So this is the simplified form of left hand side. Now the value which is at the right side of equality sign, that is A intersection B whole complement. Now we consider right hand side, and right hand side equals to A intersection B whole complement. So within a bracket we have A intersection B. So first we need to find A intersection B. A is a set whose members are 1, 3 and B is a set whose members are 2, 4. These two sets are disjoint sets. They do not have any common member, so their intersection set will be an empty set. Okay, now we will take the complement of this A intersection B. So A intersection B will be equals, A intersection B whole complement will be equals to universal set minus A intersection B. Universal set is a set whose members are 1, 2, 3, 4 and 5, and A intersection B is an empty set. So when we subtract the members of empty set do not have any member, so in the result we will get the universal set whose members are 1, 2, 3, 4 and 5. Okay, now the value of left hand side is a set containing 1, 2, 3, 4, 5, and at the right, the value of right hand side is a set containing 1, 2, 3, 4, 5. So it means both the sides are same. So we will write since left hand side equals to right hand side, hence proved. So this is the way to prove the law. First you will consider the left hand side and simplify the whole left hand side, or take the value of left hand side. Then you will consider right hand side and simplify it and get the value of right hand side. Both the sides should have same value, same set. Clear? Then you will write since left hand side and right hand side are equal, hence proved. So this is all about question number 8.